Hi, my name is Umar, and today I'll be guiding you through an important managerial economic model, cost minimization and diminishing marginal returns, and how they relate to the production and cost functions. We'll also be looking at isocost and isoquant lines to see how we can optimize them to minimize costs. We'll walk through how a plant manager at FreshBite KW can decide the optimal mix of workers and machines to produce packaged salads efficiently, especially as input prices fluctuate and technology evolves. This decision is critical because it directly impacts production costs, competitiveness, and overall company profitability. So just a bit of background on FreshBite KW. They are a regional prepackaged salad manufacturer, and they've been in the region for about 30 years. As wage rates rise and new automation options become available, they must decide the optimal mix of labor and machines to minimize costs and maximize output to achieve that maximum profitability. So before we get into all this, let's first look at what actually is a production function. A production function explains the maximum output achievable with the given inputs. So in this example, let's consider where output Q depends on labor L and capital K through the function Q equals F of LK. Let's use Q equals 10 times L to the power of 0.5 times K to the power of 0.5 as our function. For example now, if FreshBite uses 16 workers and 9 machines, the output is Q equals 10 times the square root of 16 times the square root of 9 equals 10 times 4 times 3 equals 120, which means 120 salads per hour. This function captures how inputs combine to produce output and is the foundation for making cost-effective decisions. So we can look at now short-run versus long-run production. Production decisions often differ depending on the time horizons. So in the short run, some inputs like machines are fixed, so FreshBite can only add or reduce workers. Intuitively, this makes sense because just in the short run, you can't get these new machines up and running. However, something like adding or reducing workers, you can do a lot easier than getting a whole new machine. In contrast, the long run allows adjustments of all inputs, including those machines. FreshBite could acquire or sell machines to optimize production according to the production function. Understanding these horizons matters because it determines the flexibility a firm has to manage costs or respond to changes. Now, let's look at isoquants and their properties. Isoquants represent all the combinations of labor and capital that produce equal output. Each pair of labor and capital lie on the same isoquant curve, and isoquants are generally convex because as you substitute one input for another, you need more of the substituted input to maintain output. This concept overall helps managers understand flexibility and input combinations. Now, let's look at some of the points on these isoquant curves. Let's take a look at first here Q1. Let's say that Q1 represents the quantity of 120 salads per hour, input Y being labor and input X being capital. So we have 16 workers and 9 machines. Let's say 16 is here and then the 9 machines somewhere else. We say that it lies on this curve. 16 workers and 9 machines lies about here, and we see that this produces 120 salads per hour. We can also see that 36 workers and 4 machines lies on that same curve up here, and it still produced that 120 salads per hour, and 9 workers and 16 machines down here produces that same 120 salads per hour. It shows the overall substitutability of inputs through isoquants. So now let's look more towards cost minimization using both isoquants and isocosts. So cost minimization occurs when a company chooses input combinations that meet output goals at the lowest cost. This occurs where an isoquant is actually tangent to an isocost line. Isocost lines represent all input combinations with the same total cost. So here we see our original isoquant, and then here we see our isocost line. We see the optimal point here where the isocost and the isoquant meet and they're tangent. We see this point of equilibrium, and we actually see an algebraic tangency condition where the slope of the isoquant is equal to the slope of the isocost. Intuitively, we can see this to be true, and we have that the marginal product of labor divided by the marginal product of capital equals W over R, being wage over rental rate for machinery. Since the isocost is defined as cost equals wage times labor plus rental rate for machinery times capital. This makes sense. We just sum up together all the wages and the rate for the machinery, and that's our total cost. So in this scenario, we let W equals 20, R equals 30, and C equals 600. So then we see the isocost is equal to 20L plus 30K equals 600, that being the equation for this isocost line. Next, let's look at the marginal rate of technical substitution. So the MRTS is actually the slope of an isoquant. It shows how fast FreshByte can trade one input for another with constant output. The marginal rate of technical substitution is defined as the change in K capital divided by the change in L labor. This equals to the negative marginal product of labor divided by the marginal product of capital. We see that a diminishing MRTS is existent. As labor increases, we must give up more K capital to maintain output. The implication for this is that as FreshByte uses more labor, the MRTS decreases. Substituting machines for labor becomes less efficient. For example, suppose adding one worker allows the firm to produce two machines. That means that MRTS is 2. The change in capital and the change in labor, we see that it's 2 and then 1. We also see that if we increase by one more worker, then the reduction in machines would likely be less. So as we move more and more down the slope, the MRTS would be less and less. This means that the MRTS decreases and the substituting machines for labor becomes less efficient. This diminishing MRTS impacts the choice of inputs in cost minimization as a whole. So let's look at diminishing marginal product and its relations to diminishing MRTS. In this case, we'll look at the marginal product of labor. As a refresher, the marginal product of labor is the additional output from one additional worker with other inputs held constant. So at FreshByte, we could see that 5 workers and 10 machines yields 100 salads per hour. But what if we increase to 6 workers and this yields 115 salads per hour? We see that the marginal product of labor in this instant is 15 because we yield 15 more salads while holding that 10 machines constant for capital. Increasing to 7 workers yields 125 salads. This shows an MPL of only 10. We see that our MPL reduces from 15 to 10 with each worker added to the equation with capital held constant. As that MPL decreases as more workers are added, this is the diminishing marginal returns. The diminishing marginal product of labor also leads to declining MRTS, reflecting reduced efficiency in substituting inputs. Now let's look into a more analytical standpoint with some managerial implications and calculations. Let's take our original production function Q equals 10 times L to the power of 0.5 and K to the power of 0.5, L and K being labor and capital. Let's set our output target to be 120. So then we have 120 equals Q, with 120 equals 10 times L to the power of 0.5 times K to the power of 0.5. Isolating for L and K, we see that 12 squared equals 144 equals L times K. Let's take our cost function to be the one we set before at C equals 20 times L plus 30 times K. From our production function isolation, we see that K equals 144 divided by L, and we can substitute that in to see that C equals 20 times L plus 30 times 144 divided by L, just being K, equals 20 times L plus 4,320 divided by L. To actually minimize the cost, we must derive and then set our function to 0. Thus, we see dC over dL, minimizing for cost, deriving for labor. We see 20 minus 4,320 divided by L squared, being the derivative of that, and then equal to 0. From this, we can isolate for L and solve for our optimal labor. We see that 20 equals 4,320 divided by L squared, and then L squared equals 260. Isolating, since L has to be positive, we see L equals 14.7. Thus, with L equals 14.7, we see K equals 144 divided by L, being 144 divided by 14.7 equals 9.8. Our total cost is then C equals 20L plus 30K equals 20 times 14.7 plus 30 times 9.8 equals about $588 an hour, being our optimal minimized cost with our optimal labor and optimal capital. The manager should adjust the labor and capital accordingly to minimize costs at the given price. We can also look at our analysis on the right here. We see our isoquant blue, our convex isoquant, and our isocost in red. We see that the equilibrium for these is around here, which lines up very well with our L equals 14.7, about here, we see 15 here, we see L of about here, 14.7, and we see 9.8 for K. 9.8, just under 10, we have it there, we see it. We see our equilibrium value in green, and we see that that minimizes our cost as desired. You might be wondering what would take place if just some kind of organizational innovation would improve the overall process. Technological changes can increase productivity without increasing input. This means higher returns without actually increasing the amount of labor or capital that you're putting in. FreshBite could automate some of the production process and yield an improved production function. For example, our production function could change from Q equals 10 times L to the 0.5 times K to the 0.5 to Q equals 15 times L to the 0.5 times K to the 0.5. This could be in the place of just robots, some new management, or improved training. This provides a competitive advantage coming from shifting the isoquants inward, less input for the same output. We see these equilibrium points moving in just on this line, Q3 going to Q1 on the isoquants. In summary, managers must consider diminishing returns and the MRTS to select inputs wisely. Cost minimization balances input prices and productivity. Innovations can shift production possibilities, allowing more input with less cost. For FreshBite, monitoring input prices and adopting new technology are key strategies for cost control. Thank you for watching, and I hope you learned from this video.